All right, you were supposed to have written Theorem 1, Properties of Limits, into your journal. Now this is very similar to what we did in Chapter 2, except now instead of having a function in our limits, we have the nth term of a sequence. So if we take the limit as n goes to infinity of an, we're going to let that be equal to L, and we're going to have a separate sequence bn, and if we take the limit as n goes to infinity of bn, we're going to get the value m. Now these properties behave the same way they did in Chapter 2, and just like there, these properties help us break the general term of a sequence into pieces or terms that we can work with more easily. Basically, these properties allow us to do algebra to simplify the limit. And remember that we had several methods for evaluating limits, and we tried to prioritize them. So the first thing to do when we were evaluating limits was to graph, to get an idea of what the function was going to look like. And several times earlier in this section, we've talked about how to graph a sequence. So you might want to go back and review that. The second thing that we did was to substitute in. So to take whatever n was approaching, in this case infinity, and substitute that into the nth term of the sequence. The third thing to do, if neither of the first two really help, is to simplify the expressions. And that's where all of these rules may come in and help us to be able to do that. Maybe we're going to need to do some algebra. And the fourth method that we have for evaluating limits is to look at the end behavior model. And what the end behavior model tells us is that we can assume that as we approach infinity, as we deal with very, very, very large numbers, that the polynomial will act like the highest order term in the polynomial. And we talked about all of this earlier in the year, and now we're just going to apply them to a different set of circumstances.